Hey friends, welcome back. In the last video, we learned what clustering is and how k-means work conceptually. Now let's get practical. We'll generate a synthetic dataset that mimics customers and then we will apply k-means clustering to automatically group them. Along the way, I will explain you every keyword in the code so it will feels clear crystal. First, we'll import the libraries. Pandas help us handle tabular data like row and columns. NumPy is great for working with numerical arrays. From scikit-learn.dataset, import makeblobs. So where makeblobs is a helper that generate synthetic clusterable data, basically fake customer with features we define. Scikit-learn.cluster import key means this is the main algorithm we will use to group data points into clusters. Now we'll create a synthetic dataset using make underscore blobs. So number of sample 300. It will create a 300 fake data points. Number of features 2. Each data point has two features like income and spending. Center is equals to 3. It will create three natural clusters in the dataset. Data cluster.stt is equals to 1. This controls how spread out each cluster is. Smaller values is equals to tighter clusters. Random state 42. It ensures reproducibility, so we always get the same dataset each time we run it. The function make underscore blobs return two things: x, the actual feature value; y, the true cluster labels, which we don't usually use in unsupervised learning, but it is generated for us here. Finally, we put X into a pandas data frame with column features 1 and feature 2 just to make it easier to work with. So in the output, we'll get these columns. Now we will apply k-means. K-means number of cluster is equals to 3. Random state 42, which tells algorithm we want 3 clusters because we generated the data with 3 centers. Dot fit, it trains the k-mean algorithms on our dataset. So what's happening behind the scene? K-means randomly places 3 centroids. It assigns each data points to the nearest centroids. It recalculates centroid as the mean and repeat until centroid stop moving. After training, the model has learned which groups exist in the dataset. Now get cluster assignments. Here we add a new column cluster to our data frame. K-means.label. This is an array that stores the cluster number like 0, 1 or 2 for each data point. By assigning it to data frame cluster, each row knows which cluster is belong to. So like these features belong to first class cluster. Now we'll see view cluster centers. K means cluster center. It shows the coordinate of the cluster center in the feature space. For example, it might say cluster 0 is centered around 2.5 to 7. Here it's minus 2 and between 9. These centers are useful when interpreting what each group means in business terms like average income and spending for each customer groups. Now we'll do a quick data check. Finally, I just show you the first few rows with the df.head. Now you'll see two original features. and a new cluster collapse that tells us which group each customer belongs to. Great job. We just applied k-means to a synthetic dataset. Here what we did, generate fake customer data with make-blob, applied k-means with fit, added cluster labels back to the data frame, viewed the cluster center. Now a mini challenge. Change number of clusters from 3 to 4. What happens to the result? Change cluster std in make-blobs 0. Do the clusters become messier? Third, try number of features is equals to 3. How would we visualize 3D clusters? In the next video, we will visualize the clusters with Matplotlib so you can actually see the groups in 2D space. See you friends there.